welcome to the next episode of the Klingberg Wing Mark II development. I'm Raul Klingberg, your host. For this video, I'm behind the camera. I'm going to take you on a little tour of the jigging arrangement for bonding up the fittings for the Spar carry-through. These are the fittings that the main wing panels will attach to, and the two spars that span the width of the center section of the wing. So what we see here, what we basically have are the two tubes that will be the wing attachment fittings. Actually, this tube here is titanium, and I'm going to cut sections out of it to form the 4 pieces of metal ring tubing that I need to join up the wing sections. And then those rings are going to be joined together with a composite shaft for inserting them. This one here is 4130 steel. I'm not going to be using that, but it's standing in, doing its job for the jigging process. We have the two Spar carry-throughs, which are essentially a T-section, and I have the details of how those are constructed in another video. And then we have these fittings. I'm in the process of attaching these fittings. These are 1/4 inch thick carbon fiber, and we've got 1, 2, 3, and 4 down here. 3 and 4 down on the other end. So I started by taking the bottom carry-through T fitting here and bonding on this fitting and this fitting such that the width of the Spar carry-through was set correctly at 30 inches, which is the size of the center section of the wing. And then it was very important to have the tilt this way of each one of these aligned with each other. And I used an inclinometer and a little bit of temporary jigging to do that job. So the width and the tilt this way. Now the position this way also makes a little bit of a difference. The hole for the pin has to be on center line, fairly close. But given that it's only 2 points, 1 point here and 1 point there, they define the line of the Spar carry-through. So whether they're further back or further forward a little bit or like this doesn't matter too much. But they set the baseline. Once those two are bonded in place, we have the baseline, the straight line that defines where the spars are going to lie. And then these two separate. This is just a temporary foam core spacer. These two are separate and will get bonded into the wing separately, and I'm going to use the pins to align them in the wing. This foam core spacer is the approximate height of what it's going to be in the wing. It doesn't need to be exact. We just need to be in range so that the parts are aligned close to where they're going to be in the final wing. That height is probably set plus or minus 1/8 of an inch, something like that. It's close enough. So once these two fittings were bonded in, I set this carry-through on my workbench and leveled it. I got some shimming down here, propping up this end so that it's level, and this end is just set on the base of the table. I use my electronic inclinometer here to measure that. I don't know if I can get an accurate measurement here at this time. I don't know if you can see that, but that's sitting at 0 degrees. And then I took foam core and made squares out of them. They're triangle with square edges. They're notched out at the bottom so that they can go around that fitting. And then I bonded these with hot melt glue to my workbench. It's temporary. It's easy to scrape off with a razor blade. And there's 3 of these that hold the pin tubing absolutely vertical. And this is magnetic steel, so I can stick that on there like that. We can have a look-see, and we see we're 89.9 degrees, so we're 1/10 of a degree off of vertical, and 1/10 of a degree is very, very close. It's very hard to get it ever closer than that. And this direction we're 90 degrees. So we're very, very close to vertical there. Now this being a titanium tube, not magnetic, so I just have to hold it up there by hand. We'll see where we're at. If I can hold it, stay a 1/10 of a degree off that way. And this way I am at dead nuts on 90 degrees. So we're within a 1/10 of a degree of vertical there, and that's close enough. There's a certain amount of slop in these fittings called tolerances, and it allows these pins to move a little bit side to side and fore and aft. So being absolutely vertical is not absolutely critical. So then this fitting here, I bonded onto the T carry-through piece, and I tried to get it as close to center line as possible. Once that was bonded in place, I could lower the T-beam with the fitting onto the tube such that it was the approximate height from the other beam. And then I took a couple scrap pieces of the 1/4 inch thick carbon fiber, because it's very flat, very straight, and temporarily bonded those to the fittings here, the attachment fittings, with some CA glue. I got one here and one here, and that allows me to put my level on here and level these fore and aft. Now that one's showing 0 degrees, so it's absolutely level. That's good. Then I have a balsa stick here, spacing these out so that the top one is secure, and it holds the spacing between these two. And that was tack glued in place when I had it level. There I am, varying between 1/10 and 0, so very close to level on that one. And I did the same on the other end. You'll see down here. If I can get this over here, let's see if that comes out close. 1/10 of a degree there, and the upper one should be about the same, about 1/10 of a degree. And then the top T-beam going across is, well, that says 2/10 there. This varies a little bit because of how it was made. There's a 1/10 of a degree, 1/10 of a degree, 0 degrees there. So this is ostensibly level. We're 1/10 of a degree off there. Very close. So the two carry-throughs are parallel to each other, as close as I can build them, and the holes are lined up vertically, both fore and aft. And this way, there's actually 6 degrees of freedom on this. These could tilt like this. They could tilt this way. They could be off this way, fore and aft. They could be twisted this way. And we could have a length difference between the two. And all of those have to line up simultaneously. So it's best to get the two pins set absolutely vertical, fittings put in the bottom, and then finish the top. Now, of course, I said this one's bonded in place, and I left this one free down here. This fitting is not bonded in yet. You see the clamps are on it here to hold it in place. And what I'm going to do now is I'm going to bond this fitting to the T here. Now, I'm actually only going to bond to this surface right here and here, in between here. I'm going to put a little, I'm going to take this back apart, just to take the top off. I'm going to apply epoxy in this joint, and then reset this up as you see it, and clamp it, and let it cure overnight. Now, that is the first step of the bonding process. That will bond this fitting in the correct position on the T-beam carry-through. The fittings themselves, because these are handmade, this slot where the slot slides over the beam, it is not a perfect fit. There's a little bit of gap on each side, and that gap has to be filled with epoxy and a structural filler. So I'm just going to bond to this surface first, which is a tight bond. Then I'll take the thing back apart again, I'll flip it over, and I'll use a hypodermic syringe to inject the epoxy and structural filler in that gap and fill it in. In fact, you can see here on the end it doesn't matter much, but this gap is actually pretty wide right here. I cut a little too deep into the fitting, but that's okay. There's nothing significantly structurally wrong with that. And then once all of these fittings are bonded on, I'll be coming back with the load straps. We've talked about these before, that will wrap all the way around and hold these fittings attached to the T-beams. There's actually, so we have 4 here so far. 1, 2, 3, and 4, and there's 4 more to go. There's another one that goes here on this side, above the other one, and one here, and then the same on the other side, 1 and 1 there. So that this outboard fitting, this 1/2 inch thick plate here that holds the outer wing panel, it'll actually be, I'll mount that on there, I'll get it onto the tubing, I'll undo this cape here, slide the tubing out, slide the tubing back down with this fitting in place, and then I'll come in with this fitting, sit tight on top, and then I'll bond this fitting to the spar carry through, and I'll do the same on the other side. When when the lower two are done and cured, then I'll do the upper two. And when it's all said and done, I have an 1¼ diameter reaming tool that I'm going to drop straight through. And just in case they're not absolutely perfectly aligned, I get them reamed out slightly. We have to make sure that these, I can't move them right now, they're taped in place, but I have to make sure that these tubes are easy to slide in and out. Not too much slop, but we don't want them to bind either, because as we're adjusting the wing up and down out in the field, fore and aft, up and down, and somebody's got to slide these pins in place. So they can't fit too tight and they can't be too loose. But this is the basic jigging setup. I found it best to just temporarily bond the whole thing to my workbench and use the inclinometer, electronic inclinometer, to measure everything and make sure that it's all square and level. It's been a bit of a job. This takes a couple of days. It took me a couple of days just to figure out how to jig it up properly and efficiently, and then it's taking a couple more days to bond it all together. But I thought you'd just like to take a look at one of the more challenging bonding jobs of the entire aircraft. And hopefully I'll have this done by the end of this weekend, and then I will be able to begin assembling these components into the wing's center section. And then we'll have a nice video on the whole building of the center section of the wing. So thanks for watching. Come back, watch the next episode, and more fun awaits us. Fly safe. Bye for now.